Okay, we're going to pick up from yesterday where we left off with our similar polygons. Yesterday we did scale factor, similarity statements. We addressed some of this up top. I don't know that we went through any of them. We did not do any of the finding side links, and so we're going to address that today. Let me get this set right here. Perfect. All right, so let's go back to this one. I want to make sure we are all on the same page that similar polygons. On this one, we have actually two different triangles. So we're going to highlight here the first triangle, x, y, z. So from x all the way up to y, down to z, back around. There's the first triangle. Let me do that again. X, y, z. And then the second triangle, RYS, is really this triangle. Okay. And we know from our similarity statement that we have matching parts or congruent angles. So it says angle X is congruent with angle R. I'm going to mark that. X congruent with R. Let me make these a little bit thicker. X and R, they're going to get 1. And then Y to Z, Y to Y. Okay, so Y to Y, which is a little tricky to capture, but what we're going to do is we're going to put 2 here. And I'm going to make the note that Y is congruent to Y. Y is in both triangles. And then for our next one, we're going to have Z is congruent to S. So Z, 1, 2, 3, 1, 2, 3. Now I have similar polygons. I'm going to record my angles, and I'm going to use, you can use the congruent tick marks, or you can use the tracking of the angles in the statement. Either one works. When you don't have, like we had the diagram, it didn't give us the congruent tick marks. You can just use the statement, or go ahead, put those tick marks in, and then base it off of that. So we have here angle X is congruent to angle R. And then we have angle Y, we said was congruent to angle Y. And then angle Z is congruent to angle S. I've listed my congruent angles. Then it's going to want me to write out my a proportionality or proportions with my sides. And what we're going to do, this is how I like to say it. We're going to say polygon, or sometimes you'll see me say object number 1 over polygon or object number 2. We're saying we're going to take parts of object number 1 and put it over parts of object number 2. And when we say parts here, we're going to talk about sides. We're going to take the side of object number 1, which I'm just going to call this first angle object number 1, and then this triangle object number 2. So and then we match the sides. The sides that go with the object 1 are going to match the side that goes with object 2. This is what it looks like. We're going to start with object number 1, x, y would go over r, y is equal to y, z in object number 1 over y, s in number 2. And then wrapping it up would be z, x over for the object number 1, and then s, r for object number 2. And then we're done with our proportionality statement. Those parts as ratios have equal scale factors to the other parts. So then if we jump down to number 3, just to keep going here, we're going to look at our statement. J goes with Q. K goes with R, almost went too far there. L goes with S, and then lastly, M goes with P. It gets a little chaotic. J and Q. So J and Q are both going to get 1 tick mark. K and R are going to get 2. 1, 2. R, 1, 2. L is going to get 3. 1, 2, 3. With S, 1, 2, 3. Then lastly, M is going to get 4. 1, 2, 3, 4. P is going to get 4. 1, 2, 3, 4. Okay, and we'll come back. Angle J is congruent with angle Q. Again, you can look at the tick marks or you can just follow the statement. Angle K is congruent to angle R. Angle L is congruent to angle S. And then last one, angle M is congruent to angle P. There are my congruent angles. And then I'm going to say P1 over P2, polygon 1 over polygon 2, polygon 1, polygon 2. And I'm going to write my proportionality statement. So we're going to say JK QR over QR is equal to KL over RS, which is going to be equal to LM over SP, which is going to be equal to MJ over PQ. And we're done. Okay. Now let's talk about finding side lengths. We're going to use scale factor when we start talking about side lengths. And I want to show you first over in this area of our notes, I want to show you some information here that will help us when we start to solve these. The first thing is, let me pull up my completed notes to be on the same page here. Okay. We're going to pull a scale factor. And what we need to know about a scale factor is a scale factor is a ratio. And what I need to remember from yesterday about ratios is that a ratio is just a comparison of two numbers, a number on top compared to a number on bottom. I like to use scale factors as ratios as fractions. So I'm going to do this. I'm going to draw a box for a number over another number. Okay, this is my scale factor. When we find side links or we find missing links on similar polygons, we're going to set up a proportion using a scale factor or using similar parts of one object, one and two objects to the other sides of another object. Most of the time it's scale factor. Okay, so I'm going to write another ratio. So I've got my scale factor and my other ratio. And what I'm going to say about this is these are parts of the objects or polygons. Okay. I'm going to use that framework to start solving number 4 and then onward. It says, if the figures below are similar with a scale factor of 2 to 3, find the value of x. Well, here's what I need to notice about when it says a scale factor of. The first thing I'm noticing is that the first number is for object number 1. Whatever I'm going to label object number 1, 2 is going to go to it. And we read left to right, so that's how we do our objects. We're going to say object number 1 is here. So I'm going to write this object number 1, and this is going to be object number 2. And then back in my statement here, 2 goes with object number 1, 3 goes with object number 2. So then let's pull this information and plug it into over here with our scale factor. I'm going to, let me highlight this. So I'm not going to actually write it in there. I'm going to highlight this. We're going to say object number 1 will be blue. Object number 2 will be purple. Okay. And for the sake of the notes that I copied into Google Drive, I'm going to switch that. I did object number 1 as purple. So this will match the notes that I've already posted and colored. Object number 2 is blue. We're going to take that. Then we're going to put parts of the objects, the information from the objects that we know, into our other ratio. Now, purple went with object number 1, so whatever goes in this one has to come from object number 1 as well. The side that they give me is 42. I said I wasn't going to write that in there, so erase that, Mr. Choate. What I want to do is highlight. Pull yourself together, Mr. Choate. Object number 1. Object number 1. And then object number 2 is going to go here. So let me make it clean for you. This is going to be part of object number 1. And the green one is part of object number 2. So part of object 1, part of object 2. And now I'm going to use that setup to actually solve this. So my scale factor for number 1 was 2 over 3 is equal to, I have 42 over x. For the sake of making this clean, I will take those boxes away. We have 2 over 3 is equal to 42 over x. Now what we didn't do yesterday was solving this, but in our notes, if I was to scroll back up to my notes, somewhere in here is this, what is a proportion? And I'm pretty sure I did this with every class. This cross product where you take the proportion, two ratios, and you cross multiply each other. What that looks like played out here is 2 times x is equal to 3 times 42, which is going to give us 2x times, and I don't know what 3 times 42 is. I think I already wrote it down. I did not solve this one. Let me pause and grab a calculator. I'm back. 3 times 42 is 126. And then I'm going to divide by 2, and get x equals 63. And so my missing side would be 63. Okay? So then let's look at number 5. If the figures below are similar with a scale factor of 6 over 5, or 6 to 5, so scale factor is 6 to 5, which is object number 1, object number 2. Find the value of x. Well, in object number 1, the side it's wanting me to find, we don't know what it is. They listed it as x. So I'm going to put in my second ratio x over the part that I do know, 28. This now looks like cross product where we are going to multiply and divide. So 6 times 28 is equal to 5 times x. First thing is 6 times 28 is 168. 5x, and I know this is right. You may already be panicking because it's going to give us a decimal. We're going to divide both sides by 5. 168 divided by 5 is 33.6 equals x. There is my answer. Okay, not too difficult so far. Number 6 says, if triangle ABC, which is going to be number 1, okay, is similar to triangle DEF, find the value of x. So, Mr. Choate, it didn't give me a scale factor. You are correct. But it did tell us that there are some parts that these two triangles are similar. And if they're similar, then parts are proportional. That you can build a scale factor if you have a side from both triangles. And let's see what we have. We know from our similarity statement up there that AB over DE would create a ratio, and BC over EF would create a ratio, and CA over FD would create a ratio. Let's see which parts we have. Do I have AB? I do not. I have X. Do I have DE? I have 25. What about BC? I do. I have 28. And EF is 20. And really, I can stop there because all I need is two ratios for this proportion. So I am going to stop there. And if I notice, when it comes to CA or AC, I don't have anything. Same thing for D. I couldn't do anything with those anyway. So I have this ratio, or proportion I should say, down here that I can cross multiply. So x times 20 is equal to 25 times 28. And I'm going to move this up. Oh, goodness. Okay. Yeah, move this up. So we have 20x equals 25 times 28 is 700. I'm going to divide by 20 on both sides and get x equals 35. So x would equal 35 here. Last one we'll do here is if PQRS is similar to WXYZ, find the value of x. Okay, so again, my first object, my second object, just helps us keep everything in order, and it matters. We know from our similarity statement PQ over WX is equal to QR over XY, which is equal to RS over YZ, which is equal to SP over ZW. And what you're looking for is where the missing value is. So you're looking for what ratio is going to include the x, and then just another ratio. So PQ. I don't have anything for PQ. I'm not going to use it. QR. I don't have anything for it. I can't use it. RS is where my x is. So x over YZ is going to be over 32 is equal to SP, which is 75, over ZW, which is going to be 40. So I'm going to rewrite this x over 32 equal to 75 over 40. Again, we're going to cross multiply. X times 40 is equal to 32 times 75. 40x equals 32 times 75, and that's 2400. Divide by 40, and I get x equals 60. So that missing side where the x is would be 60. Okay? Looking at your assignment for today, 6.3, practice A. This was yesterday's assignment. You're doing 6.3, practice A, 9 through 15. It's the backside of yesterday's assignment. In your Google Classroom, I've highlighted what you're looking for here. 9 and 10 says polygons are similar, find the value of x. 11 and 12 says use a similarity statement to, notice, find the scale factor of the polygon on the left, so it's telling you which one comes first, left to the polygon on the right. Then find the perimeter of each polygon, add up all the sides. 13, 14, and 15, you do not need to do what's crossed out in red. You do need to do the yellow. Then find the value of the variable. So you're finding what x is in 13, what y is in 14, and then number 15, you're solving this question and then answering the question, is the shadow similar to the kite? That's all I have for you. There's a video from yesterday if you want to go back to your Google Classroom and listen to it quietly at your desk. Be good for the sub. They're leaving me a note. I hope you have a great weekend, and I'll see you on Tuesday.